Hi, this video is designed for you to practice some of your polynomials for the final exam. Feel free to pause the video, try the questions yourself, and then check the solution with me. For number 1, you're going to identify the degree of each polynomial. Degree is determined by the variable exponents, and if you have a polynomial that is more than one term, you're going to determine the degree of each term separately and then take the highest term as the entire polynomial's term. So when we look at the first one, we have a trinomial here. 4p squared, p squared means that this is a degree of 2. That's our first term. Negative 7p is our second term. That's a degree of 1, because the variable is to the degree of 1. And then constants don't have a degree. So the first term has the highest degree, therefore this entire trinomial is a degree 2 polynomial. For the second example, we have a 4-term polynomial. So we're going to need to add some exponents. For the first term, we have x to the power of 5y squared. So we're going to add 5 plus 2. So this is a degree of 7. And the second term, we're going to add our exponents. This is a degree of 8. Third term, remember that the z here is to the first degree, so that's a degree 3. And the last term, z is to the power of 4, that's a degree 4. So we can see that the second term is a degree of 8, therefore the entire polynomial is a degree 8 polynomial. For our second type of question, we're going to add and subtract to simplify the polynomials. And so remember, when you're subtracting, it means you need to distribute the negative before you can remove brackets. Here we have a binomial that's being added, so we're just going to take the 9x squared plus 6x and remove the brackets. And the same with the second binomial. We're just going to be adding on 5x squared plus 9. For the subtraction, we're going to have to distribute the subtraction or distribute the negative to each term of the trinomial in the brackets. That will switch the sign of everything inside. So the 5x squared, which is positive, becomes a negative 5x squared. The negative 4x or the minus 4x becomes positive or plus 4x. The negative 12 or minus 12 becomes its opposite, becomes a positive 12. Once we've removed the brackets and done the distribution, now we can collect like terms, and we're going to write in descending order. So we're going to combine our x squareds first. We're going to take the 9x squared minus the 5x squared, which is 4x squared. Our x's can be collected. 6x plus 5x plus 4x is a positive 15x. And our constants we collect last. 9 plus 12 is 21. Simplified, this is 4x squared plus 15x plus 21. Third type of question reviews multiplication and division. First, we'll look at division. When you are dividing a polynomial by a monomial, it means you're dividing each and every term by the monomial in the denominator. You may find it useful to rewrite each term and do the division separately in order to stay organized and keep your sign working out. So I'm going to rewrite each term above over top of 2x because I'm going to be dividing each and every term by 2x. Remember, when you divide, you're going to be dividing coefficients but subtracting the exponents of the like bases. So I'm going to indicate that when I have x, that means x to the power of 1. Now I'm ready to divide. 4 divided by 2 on the first term is 2, and x to the power of 4 divided by x to the power of 1 means I subtract my exponents. This gives me x cubed. Second term, negative 6 divided by 2 is negative 3, x cubed. We're going to subtract 1 away, gives us x squared. Third term, 2 divided by 2 is 1. So I could either write it, or I can take that 1 away because it's that invisible coefficient. That's a positive 1, and then I'm going to subtract my exponents. That's just x to the power of 1, which is x. The last term is negative 10 divided by 2, which is negative 5. x1 subtract 1 means we have x to the power of 0, which is equal to 1, and 1 times negative 5 does not change it. So simplified, we have 2x cubed minus 3x squared plus x minus 5. You can have the 1 coefficient in front of the x, or you can take it away. For multiplication, we're going to go ahead and we're going to distribute. So we're going to multiply coefficients, and this time we're going to be adding our exponents. So we're going to take the negative 4 times 6. That equals negative 24, and then x to the power of 1 multiplied means we add our exponents. 1 plus 1 gives us 2. For the second term, negative 4 times 5 is negative 20, and we have x and y. They're different, so we can't do any adding of exponents. We can just combine them. The last term, negative 4 times negative 5, is positive 20. And again, x and z are different, so we can just put them together. Simplified, we have negative 24x squared minus 20xy plus 20xz. Fourth type of question to practice is power laws. When you have the same bases, you apply your power laws, and you can simplify expressions quite easily. When we see a base of 5, 5 to the power of 8 times 5 to the power of 6 times 5 to the power of 12, we don't have to use our calculator to expand and solve. We're looking to simplify, and we're going to apply those laws. So we're going to keep our bases, and we're going to add exponents when we are multiplying. So 5 to the power of 8 times 5 to the power of 6 means we add 8 plus 6. This becomes 5 to the power of 14. Now we're ready to do our quotient law. We're ready to divide. And we are not dividing 5 divided by 5. Those are bases, like x to the power of 14 divided by x to the power of 12. So this is very important. We keep the base, and we simply apply the law. To simplify, we subtract our exponents. So this becomes 5 to the power of 14 minus 12, which is 2. We could evaluate this now quite easily. 5 squared is 25. But because the question is asking us to simplify, we don't have to evaluate. So read the question carefully to determine what they're looking for. For the next example, you may find dealing with variables like x and y easier because there is no option to evaluate. We're simply looking to apply a power to a power here. So we determine that the squaring outside the brackets actually applies to everything inside the brackets, even the invisible coefficient. Now we know that 1 squared is just 1, so that one we don't actually have to show. But for our exponents, we're going to multiply in order to show raising to a higher power. So x cubed to the power of 2 means we're going to multiply our exponents, giving us x to the power of 6. And y squared, squared again, means we multiply our exponents. This is y to the power of 4. So simplified, we have x to the power of 6, y to the power of 4. The last kind of polynomials question you often face is a substitution question. Remember, when you substitute, use brackets and use BEDMAS rules. Here, x is equal to negative 4, so we can evaluate or solve. We're going to use brackets and substitute negative 4 everywhere we see x. Then we determine using BEDMAS what to do first, second, and so on. We see that we have a squaring, so exponents come first. We're going to do this first. -4 squared means -4 times -4, which results in a positive 16. So we're now going to have 2 multiplied to a positive 16. Minus 7 multiplied to -4 plus 12. Now we have multiplication, subtraction, multiplication, addition. We can do both sets of multiplication. I'm going to show the multiplication here. This one is straightforward. It's positives. 2 times 16 is 32. I'm going to carry down the minus sign, and I'm going to do 7 times -4. And that's going to be -28. And then I copy down my plus 12. At this point, I have subtraction and addition, and I can work left to right, but I also recognize that I'm subtracting a negative, so I can use same, change, opposite to get rid of that subtraction and change the problem into 32 plus 28 plus 12. Once everything is addition, I can go in any order I want. I'm going to combine mentally 28 plus 12, which is 40, and then add 40 to 32. So my result here is 72. Evaluated, this polynomial equals 72 when x is equal to -4. Polynomials is fun, but it takes a lot of practice. So I hope that you found this video helpful and that you can take some time before your final to go through the rules and the practice in this unit.